You may have heard that our world or the Earth is located in what is called the solar system. The solar system is a vast amount of space in the Milky Way galaxy. It is made up of the Sun and other planets that are constantly revolving around the Sun in what is called an orbit. Some of these planets, like our Earth, also have satellites called moons that revolve around them. For so many years, it was believed that the Earth and other planets revolve around the Sun in orbits which are circles around the Sun, until a German mathematician called Johannes Kepler proved that these orbits are not circles but ellipses. An ellipse is a form of a circle that looks longer at one side. An example of an ellipse is the shape you get when you hold a circular wire and press it at opposite ends. With this, Kepler established three laws which describe the shape of the orbits of the planets around the Sun, the area the planets cover as they revolve around the Sun, and the time it takes these planets to revolve around the Sun. Let us look at all three laws and explain what they mean. The first law states that planets travel in orbits that are ellipses around the Sun, with the Sun at one of its foci. Foci is the plural form of focus. This law tells us the shape of the orbit of a planet moving around the Sun and also the position of the Sun in the orbit. To understand this, let us look at what are the foci of an ellipse. Assuming this is our ellipse, we can draw a line along the long side. This is what is called the major axis. The foci are 2 points along the major axis with equal distance from the middle, such that the sum of the distance from any point along the ellipse is constant. So if these are our foci, then the sum of the distance from this point to both foci will be equal to the sum of the distance from this point. What the first law says is that assuming this is the orbit of the Earth, the Sun will be at either focus. So it will look like this. The second law states that the line joining a planet and the Sun covers equal areas at equal intervals of time. Again, to explain this, let us look at our ellipse with the Earth and the Sun. If we draw a line from the Sun to the Earth and the Earth travels from this point A to a point B, it will cover an area like this at a time t. This means if the Earth travels for another time that is equal to the same time t, it will cover the same area. But looking at the ellipse, the distance and area from the Sun are not constant. The distance from this point A to the ellipse is longer than that from the Sun to point X. This means for a time equal to t, the Earth will cover a larger area. This implies the speed the Earth moves around the Sun is not constant, but is faster when the Earth is closer to the Sun and slower as it goes further from the Sun. Which makes sense because the velocity of the Earth will vary with the gravitational pull of the Sun on the Earth. The closer the Earth is to the Sun, the greater the pull, the faster the movement. Now let us look at the third law. The third law states that the square of the period of any planet is directly proportional to the cube of its semi-major axis of orbit. Note that period in physics means time taken. Let us look at our ellipse one more time. The distance from the center of the major axis to the ellipse along the major axis is the semi-major axis. If we call this distance capital D, then we can write this law mathematically as t squared is directly proportional to d cubed. This can be proven by equating the centripetal force to the gravitational force. The Sun's gravitational force pulls the Earth with a force that is equal to the centripetal force with which the Earth moves around the Sun. In our lesson on acting towards the center, we said the centripetal force for an object traveling in a circular motion is equal to the mass of the object m multiplied by the square of the angular velocity omega and the radius of the circle. Also, in our lesson on mass attraction, we said the gravitational force between two masses is equal to the gravitational constant g multiplied by the product of the masses divided by the square of their radius, where capital M is the mass of the sun and small letter m is the mass of the earth. Now, equating these two, we can cancel both masses and cross multiply the radius, and we have omega squared is equal to g capital M over r cubed. Omega is equal to 2 pi over t. This implies omega squared is equal to 2 pi squared over t squared, and this gives 4 pi squared over t squared. Making t squared the subject of the formula, we have t squared is equal to 4 pi squared r cubed over gm. From this, we can see that by making 4 pi squared over gm a constant, t squared is proportional to r cubed. T is the period and r is the semi-major axis. And this verifies Kepler's third law. So keep studying and see you in another lesson.